And welcome back to our classroom. So today we are talking about the measures of variation and skewness. Okay, so this is the last block unit in the first block of MMPC 4. So let us get started. We'll talk about measures of variation first. So what is variation? What do you mean by the term variation in data? It means your data is changing, it is varying. So what is it actually? The measures of variation actually are quantities that can be used to describe the variation, that is the dispersion or spread or scattering of individual values around a central value. So we found out the central values, right? The measures of central tendency, like the different types of mean, medians and mode, quartiles, deciles, percentiles, all those things we found out in the last unit, that was unit 3. So now once we have the central data, we often require to find whether our data is, how much is the dispersion, is our data highly dispersed or is it tending to concentrate or cluster together your central value. That particular information is actually quite useful for us in our analysis. Okay, so the measures of variations are used to find this out, how much our data is spread across. So the main reason why we are doing this is to find out how much reliable our central value is. Like for example, if our data is a highly spread out dispersed data, okay, with values all around the place, the central tendency measure, like maybe the mean which you're finding for that data set, would tend to average out everything. Like it's a very smoothed out data which is actually not representing any data point in that actual data set, right? No actual data point will be represented by the mean in case of a very much scattered or spread across data. So in such cases, when we find the measure of variation and we find out that it is a high variation data set, the variation is very high, then we should take that measure of central value or that central value with a pinch of salt. Okay, that is the main point. Same way, if like suppose in India you find that the income level is not much varied. Okay, the average income level you can see maybe is not much dispersed, but perhaps some other country you will find that the variation is very high. That is, there are people at both ends of the spectrum. Some are ultra super rich and some are very poor. There is not many people in the middle ground. Then you would find, if you check the variation of such a income data set, you will find that the dispersion is very high. So at that in so we can compare the variation of India and that other country to find out inferences from it. And it also can help determine the nature and the cause of variation, so that we can control the variation, like if it is a positive variation or is it a negative variation, and we can go and find out why there is this variation, and maybe we can bring out policies which can help control this variation. So what are the measures of variation that we will be studying? Well, there are two types of variation measures which we'll be studying. One is the absolute measure and the other is the relative measure. When we are talking about absolute measure, we are trying to find the dispersion within a single data set, within itself. And a relative measure is by comparing two data sets or comparing two different values. That is a relative measures. Okay. So for each absolute measure, we have a relative measure as well. Like for example, the absolute measure of range has a relative measure called coefficient of range. If it is average deviation, we have coefficient of average deviation. Quartile deviation, we have coefficient of quartile deviation. For standard deviation, we have the coefficient of variation. So well, let's go and see one by one. Okay, what is range? Range is the difference between the highest and lowest value found in a data set. That is range. So we can use it for quality controlling, share price variation, finding out weather forecasting. Like if we can find the range of maybe data goes from -3 degrees to maximum 33 degrees, then in that case our forecast should not shoot up to 45 degrees on a particular day all of a sudden, right? So it can help us to adjust our weather forecasting. Or any such forecasting measures we can use range to quality control. Then let's talk about its relative measure, that is coefficient of range. It tells us about the spread of data. That is, if it is a very high coefficient of range, then we should understand that there is high variation in the data values. And if it is low, means the data points tend to cluster close to each other. That is what is meant. the next measure of variation we'll talk about is the average deviation. The average deviation is the approximate measure of the variability per value within a dataset from the mean or the median. And the coefficient of average deviation is the relative measure with which we can reference the average deviation. Same way, quartile deviation is a measure of dispersion depending upon the lower and upper quartiles, known as the quartile deviation. So range, when we spoke about range, we checked the lower and upper values, right? Same way, quartile deviation, we'll take the difference between the, what you can say, the upper quartile and the lower quartile. And coefficient of deviation is the relative measure, which is with respect to the quartile deviation. And standard deviation is what we all know, right? It is quite frequently used. It is the most frequently used, and the coefficient of variation is also mathematically very important because we use them in further treating data a lot. So what is standard deviation? It is the quantity expressing by how much the members of a group differ from the mean value of the group. So we have the mean value and we are trying to find out how much the members of the group, that is the individual data points, differ from the mean value for the group, that is expressed by the standard deviation represented by sigma. Now here mu represents the median, mu represents the mean. Okay, next is the coefficient of variation. So coefficient of variation is naturally a relative measure. It represents the ratio of the standard deviation to the mean, and it is also a very useful statistic tool for comparing the degree of variation from one data set to another, even if if the means are drastically different from one another. So perhaps when you try to compare two data sets, it is not necessary that the means are close to each other or the means are quite comparable or within the range of each other. No, sometimes the data sets would have highly different and drastic means, and if we want to compare such two data sets, then the coefficient of variation will be the best choice for us. And the next concept which comes into picture when we talk about data is skewness. So up till now, all our data were assumed to be normal distributions. Like the data is assumed to be like this, right? The graph, if we plot the data points, we were expecting to get such a distribution. But that is not always the case. Sometimes data would tend to cluster to one of the areas. Like sometimes we might have more lower values or more upper values. And such a identification is also very important in some cases. So skewness is a measure of the asymmetry or the distortion of our distribution. It measures the deviation of the given distribution from a symmetric distribution like a normal distribution. So when our measures of variation found out the dispersion, skewness measures the deviation. So and any distribution can either be skewed to the left or the right, that is positively skewed or negatively skewed. Suppose this is my symmetric distribution over here, then a positive skew means then the number of outliers would be more to the right hand side. If it is a negative skew means number of outliers would be more to the left hand side. Now, to measure skewness, we generally make use of the Bowley's coefficient method or Pearson's median skewness or Pearson's mode skewness. Now, when we use Pearson's mode skewness is when we have a very strong mode exhibited by the sample data. And median skewness we'll find out especially in cases of bimodal or multi-models data sets, or when the mode is a very weak mode. That is, there is, even though maybe the mode value represents, there are five points with the same value, but all the others might be like 4 or 3 or like that. So our mode is actually not a very strong mode. So in such cases, we go for the median skewness. And the other one is Bowley's coefficient of skewness. That is used for open-ended distributions, where we have the first class would start with lower than or less than, and the very last class will end with more than, like that. So the open-ended distributions, what we do is, rather than going for finding the mode or median, we go and find out the quartiles and use that to find the skewness. Now, once we calculate the skewness using Bowley's coefficient of skewness or Pearson mode skewness or Pearson median skewness, you'll get a number, right? You'll get a number. If that number is 0, then that means your distribution is a normal distribution. There is no skew. If you get a greater than 0 value means your curve will be positively skewed. And if you get a less than 0 value means your curve is negatively skewed. Now, how do we interpret this skewness? That is very important. Now, you found out the data is skewed, or you found out the data is not skewed. Now, what? What does that mean? That is what is important for us as business administrators. We might not have to go and do the calculation. Somebody in our team might do the calculation for us and bring it to us. But it is us who have to look at that calculation and then decide based on that calculation what my next business action should be, right? So interpreting skewness is what is more important to us than anything. So what is it? How do we interpret it? Skewness actually includes the extremes of the data set instead of focusing on only the average, right? So when we talk about the returns on investments, such distributions, or when the investors are seeking short-term and medium-term security positions, we need to talk about the skewness of the data set. Okay, suppose we are going for the long run. Long run investments means average, if I can get so and so rate of return, I am fine with it. But when we are going for a very short term position, like when we are doing short tradings or intraday tradings and all, very small term investments, right? At that time, the skewness is very important to for us to understand whether or not we'll get a loss or we can get a gain. So, same way, financial models which try to estimate an asset's future performance, okay, is generally considering a normal distribution, like the rate of depreciation or appreciation of an asset. We generally consider that it will follow a normal distribution, but it may not be the case. The data might be skewed, and if we can find that skewness, then our financial model will be much more accurate. And if the return distribution shows a positive skew, so in either of these cases, if I'm getting a positive skew on my distribution, then what it means is that I can expect recurrent small losses and few large returns from my investment. And conversely, if I am finding that it is a negatively skewed distribution, means I'll get recurrent small gains, but at times I might even get a very huge loss. So now that we know this, we can correctly decide upon whether I want small wins and a large loss, or large wins and small losses on the way. So depending on that, we can decide our next move. That is the importance of the skewness. So I hope you understood the measures of variation and skewness. And with this, we are coming to a close of our block 1.